Here we are at beautiful Sunrise Woodland Hills Little League, ready to go over the chi-square analysis problem.
There's no crying in baseball!
Yeah, guys, there's no crying in baseball and there's no crying in genetics. Let's just do the chi-square. Okay, this was our example for testing for linkage, right? You were given these numbers and you were told that's their total if you add it up, and then, right, are they linked? That's usually our question. Our null hypothesis is always not linked. Why? Yes, because then we can expect a 1-to-1-to-1 ratio. So what do we do first? Well, let's find the observed values. Okay, the observed values are just these. So the observed values for which ones? Which category? Which are these? The two higher numbers, what are they always? Parental. The two lower numbers, what are they always? Recombinant. If you didn't get this far, then that's a problem and you need to go back and rewatch.
Well, excuse me!
Okay, you can always go back and rewatch the lecture captures. Not a big deal. Don't worry about it. So those are our observed values. What are our expected values if it's not linked? We should get 25% of each category, right? So what do we think that is? So our observed for the parental is going to be this number together, which if you do the math, ends up to be 777, and then the recombinants together are 470. Okay, those are our observed values. What about our expected values? We would expect those values for the parental to be 623.5. Oops, 623.5. And the recombinant class is expected. What's the recombinant class expected? Well, the exact same thing, right? It's just half of the total, 50%. Remember, we only put them into the two classes, never, ever, ever into the four classes. Okay, we're grouped into the two classes because degrees of freedom is 1. Number of classes minus 1 equals degrees of freedom. We always, always, always use degrees of freedom for the chi-square when we're testing for linkage. Okay? Yes. Okay, come on. Come on. Come on.
There's no crying in baseball!
Yeah, so come on. Okay, now we need to set up the chi-square value. We have all the things we need, now we need to set it up. So let's zoom and give myself a little more room, because I drew too big and I scribbled all over. So we set up our chi-square, right? The chi-square is equal to observed minus expected squared. So observed for class number 1, or parentals, which you can do these in either order. You can do the math both ways and find out. Squared over expected plus observed minus expected squared over expected, right? And what does that equal? If we do all that math all together, that equals 75.6. So do we accept? That's not what I wanted. Or accept? Yes, thank you. Or reject. Which one should we do? Well, let's look at our chart. Okay, here's our chi-square values. Here's our critical cutoff, right? Our p-value of 0.05, that's our cutoff. Anything below less than 3.84, we accept the null hypothesis. That would be, we say, yes, it's not linked. That's our null hypothesis. Or we reject it. If we reject not linked, it's not linked, which essentially means linked. Okay, so is 75, what was our value? 75.6? That was our chi-square value. Is that greater than or less than 3.84? What do you think? What do you think? Yes, it's greater than. Okay, so it would be way off the chart over here. We definitely reject the null hypothesis. Those genes are linked. All that's left for this lecture capture is...
Now's the time on sprockets made me dance.